Yogah Karmasu Kaushalam.
I welcome you all in the online refresher course in chemistry hosted by Department of Chemistry, Gujarat University, Ahmedabad. On behalf of Dr. Jagdish Joshi, Professor Director UGC HRDC, and Dr. Dilip Wasawa, Assistant Professor, Refresher Course Coordinator, Department of Chemistry, Gujarat University. I am Nikita Mishra from Department of Chemistry, Gujarat University. Welcome you all in the session of Dr. Naved Malek, Fellow of Royal Society of Chemistry, Associate Professor, Department of Chemistry, SVNIT, Surat. Dr. Malik completed his graduation from JP Arts and Science College, Bharuch, and post-graduation with Analytical Chemistry as a major subject from South Gujarat University, Surat in 2003. He has been awarded the PhD in Chemistry in 2007 by Veer Narwal South Gujarat University, Surat. He joined SVNIT Surat in August 2008 as an assistant professor in chemistry. He has worked as a postdoctoral fellow at University of Sao Paulo, Brazil from November 2014 to October 2015. He has more than 17 years of research experience and 11 years of teaching experience. He is co-author of 4 book chapters and 82 research papers in various journals, international and national repute, and has more than 1216 citation with H index of 21 and I-10 index of 45. In his research interest, the thrust area includes designing novel surfactants with ionic liquid characteristics, their aggregation behavior in various external environments, sol gel in ionic liquids and their applications in materials, chemical thermodynamics and solution chemistry of pure and multi-component system containing ionic liquids and deep eutectic solvents, carbohydrate chemistry including cellulose chemistry. He has supervised many research projects like Twescast Fellowship for Research and Advanced Training in 2021, UGC CSR Collaborative Research Project, Award of Beam Time by Australian Centre of Neutron Scattering in 2017, Department of Science and Technology DST, New Delhi, Council of Scientific and Industrial Research CSIR, New Delhi. In his professional awards, he received various fellowships. In 2021, Fellow of Royal Society of Chemistry, 2021 Twescast Visiting Expert Fellowship, DST Young Scientist Award in 2010, FAPSP Postdoctoral Fellowship in 2015, State of Sao Paulo, Brazil. He is also a member of scientific societies like Fellow Member of American Chemical Society, Fellow Member of Royal Society of Chemistry UK, Member of American Oil Chemists Society, Member of Indian Council of Chemists, and Fellow Member of Indian Thermodynamic Society. He is also a reviewer in many national and international journals with high impact factor, reviewer in the project of Department of Science and Technology DST, Government of India, Science and Engineering Research Board SERB, Government of India, National Science Centre Poland, and Australian Nuclear Science and Technology Organisation.
Hi, good morning to all of you. Welcome to the third online chemistry refresher course 2022-23 organized by Gujarat University. I'm thankful to the organizing committee for giving us an opportunity to introduce the topic against you. Myself, Dr. Naved Malek, working as an associate professor at Department of Chemistry, SV National Institute of Technology, Sardar Vallabhbhai National Institute of Technology, Surat, Gujarat, which is one of the premium institute for the technological innovations. Today we are going to see the most important topic for industry. You touch any of the industry, and the topic which we are going to see today will be helpful in every corner of the industry. We are going to see chromatography. Chroma means color and graphy means how to represent this color in a graphical form. So we are going to see that what is the importance of the chromatography, Before going towards the importance of the chromatography, we will see the definition of chromatography, which are the types of the chromatography, and how the chromatography works, means basic principle of the chromatography. On which basic principle it is working, we will see. And different theories of the chromatographical principle, actually, the separation. After this particular basic idea about the chromatography, we will go towards the advanced chromatographical technique, which is the high performance liquid chromatography, or known as the HPLC. We will see that how this HPLC works, how it functions, how the instrumentation is working, and which are the different parts of the instrument, and what are the application of each part. Then we will see the basic applications of the chromatography and how it can go further for the advancement. Before wasting your time, let me share my screen to all of you. Okay, great. Chromatography from basics to the advanced applications. Myself, Dr. Naved Malek, working as an associate professor at Sardar Vallabhbhai National Institute of Technology, Surat, Gujarat, India. As I told you, I'm from Gujarat. I'm from Gujarat. I'm from Surat city. Surat city is well known. It's well known as a diamond city, silk city, the city of the sun, and we are the fastest growing city in Asia. These are some of the glimpses of the Surat city. You can see the Gaurav Path. This is our old age building of the Surat Municipal Corporation, the ring road of the Surat at the night time, the redeveloped Gopi Talab of Surat. This is the busiest area of the Surat, which is known as the textile industry. So we can say the textile market is there. This is a beautiful scene from the Vesu area, close to the SVNIT. This is our institute, Sardar Vallabhbhai National Institute of Technology. In 200 acres, it's been there. And since 1961, it is there. It means it's an old institute, earlier known as the Regional Engineering College. In 2002, government changed all the regional engineering colleges to the NITs. So the status has been changed from RECs to NITs. And from Sardar Vallabhbhai's name, the name has been given the Sardar Vallabhbhai National Institute of Technology. And in 2007, the institute is awarded as the institute with national importance status. We are running so many UG and PG courses. Some basic UG courses are there actually, and advanced PG courses are available at NIT. We are also running 3 MSc courses, which are basic science courses, like physics, chemistry, and mathematics. Degrees are being awarded. Specialization, we generally give so many specialization in master's degree of pure sciences also. Recently, we have introduced the elective courses in a basket form. Means student can choose the elective course based upon his or her interest and gain the basic to very advanced knowledge of that particular. So we are also on the top of the NIRF ranking. Let us start with horrible years 2019-20, the outbreak of COVID. In world, no one was knowing what is going to happen next, how it is spreading, how it is happening. Many myths are there, many facts are there. But among all these myths and facts, these are the facts which we have experienced after the outbreak. Till the world knows about its severity, many lives have been lost. And then we came up with the kits. The kits who saved many lives. We have seen these kind of the scenes everywhere, every corner of the city. Whenever you are entering to the city or you are exiting it. So in the entrance, many municipal workers or many government officials, they were testing you. And within a fraction of a second, you have been allowed to go or you have been isolated based upon the test result. And everyone was wondering what these people are doing. And then we came to know that, yeah, these are nothing but the rapid antigen test kit or the COVID-19 kit. You must have seen, many of us have experienced that either saliva was taken actually from us and put a drop on this particular kit. And the personnel will say whether you are positive or negative. If you are positive, then you have been isolated, you have been referred to the hospital, or you have been given some of the medicines and asked to isolate yourself into the home if you are traveling alone. What was there in this particular kit so that the results are so quick and handy and cheap also? We will come to know that how it happens. This is due to the chromatography. Thanks to the chromatography technique that such kind of the innovations are possible. Second innovation, masks, who saved so many lives. As per the government guidelines, we have to wear the N95 mask. Why particular guideline been given? Because these masks are having certain layers which can separate, which can stop the particular virus so that it cannot come in your contact and you are not infected. By this way, so many lives have been saved. Not only your lives, but you are saving the other lives. One more innovation. The most beautiful experience for any woman is to get pregnant. But in earlier days, so many techniques have been were discovered. But ultimately, a woman has to go to the hospital, to some of the clinic, and have to taste herself that whether she is pregnant or not. The test will take a day or two. The results will come in a day or two. And by that time, she has to wait. But now, no need to wait for that. Instantly, you can purchase the kit at your home. The moment you think that now it's the time to test, just test with few drops of the urine and the results will come against your screen, whether you are positive or negative, whether the good news is there or not. Very handy, very cheap, and results are so accurate that you can rely on that results. How does it happen? Thanks to the chromatography. This is just one application of the chromatography. That a good news is at your hand. Now we are from Gujarat, a dry state, but this is for everyone across the globe. You can't drink and drive. You can't mix both. Either you drink or you drive. You can't mix both, for sure. But how a police personnel came to know that you have drunken? You must have observed such kind of the tests whenever you are entering a city or leaving a city. That a traffic police is going to check you. And with so accuracy, that guy is telling you whether you are drunken or not. And you can't argue with them because the result is accurate. The result is accurate. How comes this instrument will tell a perfect result? Thanks to the chromatography. That it will tell whether the alcoholic percentage are there in your body or not. Now, the most important application of the chromatography. How to determine the purity of the drug, the active pharmaceutical ingredient which you are taking. You must have observed that several medical professionals, they are prescribing specific drugs. Generally in India, doctors prescribe the medicines based upon their trade name, the company's name the company has given, not from the API's name or the active pharmaceutical ingredient needed to cure that particular disease. Generally in abroad, in foreign countries, they are prescribing the content that you have to take paracetamol. They will not prescribe that you have to take XYZ medicine, that you have to take the dolo. They will not prescribe that you have to take dolo. Yeah, they will prescribe you have to take paracetamol. Coming to this way, actually, how the purity, that what a particular drug you are taking, that is pure 99.99%, how the drug is decomposing, how the scientist comes to know that your drug is now not good to take, now it is degraded, now it is harmful, you can't take it, expiry date, in simple word you can say, that how the expiry date is recognized for the particular drug. This is all due to chromatographical technique. Why certain medicines of a certain company are so expensive than the other companies. We will put the marketing strategy aside and come into science only. Then definitely some of the companies, they invest so much and they take so much of care for the purity of that particular drugs, because they care human being, human lives matters for them. So how the purity is determined, and the only answer is chromatography. With the help of the chromatography, you can determine the percentage purity of your particular drug. And this you must have seen in your kitchen. I always believe in kitchen chemistry. From this, you have been separating either the solid from solid, or you have been separating the solid from liquid, solid from liquid, solid from solid. This is based upon the size of the solid particles, and this works on the physical appearance of the particular particles. One is into the liquid form and one is into the solid form. You are separating out both. Here, both are into the solid form, but we are separating at the basis of the particular size. Why exactly I put this? Because chromatographical principle also works on this particular. So let us start with chromatography. How all these are interconnected. These all are interconnected through chromatography. So what is chromatography? Chromatography, the word itself is chroma means color and graphy means writing. It's coming from the Greek word. So separation of the mixtures is known as the chromatography. We are passing an analyte or a particular substance whose analysis is to be done through a stationary phase, which is filled into the particular long glass column or any of the column. And then separation is achieved based upon the affinity of that analyte towards the stationary and mobile phase. So when we are passing an analyte through the mixture of the solid stationary phase, it distributes among the stationary and the mobile phase through the sorption and desorption steps. And based upon that, the separation has been achieved. How it works? So separation is due to difference in the distribution coefficient. What does it mean? Distribution coefficient means how it is distributing among the stationary and the mobile phase. The more the affinity of your molecule with the stationary phase, it will stay longer into the stationary phase. And the least the affinity, it will come out very fast. Let us see one example. You can see over here that this is a mixture of several analytes. This is our sample in which several analytes are mixed. I have distributed them according to their shapes. Let us say spherical, square, and triangles are there. These spherical particles are having the high affinity towards the stationary phase. It loves the stationary phase. And as it loves, what will happen? It will spend more time with the stationary phase particle. And these triangles, they are having no affinity or very least affinity towards the stationary phase particle. So what it will do? The moment you are passing the mobile phase, it will come out very quickly. So when you are passing the mixture through the column having the stationary phase with the mobile phase, what will happen? These guys, these triangles are having least affinity. So they are coming out of the column very quickly. And these are having little bit less affinity. So the square particles will come out later on. And as these spherical particles are having the highest affinity, it will stay and it will come out very late at the last of the column. So by this way, the separation is achieved. Same example is been given over here with the help of the color diagram. That how the separation is been achieved. So in chromatography, what is the principle? When you are passing a sample, that sample undergoes several sorption, desorption processes. Several sorption, desorption processes through the stationary and the mobile phase. And mobile phase carries the particular molecule along with it. You can see this mobile phase is moving because it is moving through the column. Stationary phase is remaining stationary into the column. So this mobile phase carries your sample molecule along with it. And when it is carrying the sample molecules, suppose a molecule is having higher affinity, that will stuck over here. Rest of the molecule will go ahead. And by this way, the separation is being achieved. So how it has been done? First of all, your column has been filled with the stationary phase particles. Then compound is placed on the stationary phase particle. You have to introduce your compound of interest. Then you have to pass the mobile phase through the stationary phase. So what it will do? Mobile phase will solubilize the particular components and it will carry the components throughout the column. So individual components at certain distance through the stationary phase it will carry, and based upon its affinity towards the stationary phase, distribution among the stationary and mobile phase, your particular process runs and your analysis has been done and you will get the separation. Now, why chromatography? What are the applications of the chromatography? Chromatography is not only used for the separation, but it is useful to analyze the compounds present in your particular sample. Which particular components are present means to identify them, whether your drug is pure or not, and if it is pure, how much is the purity? What are the impurities present in your drug? Can be done with the particular chromatography, and how much percentage of the impurity is there? How much percentage your sample is pure, your API is pure? All can be done with the help of the chromatography. You can do qualification as well as quantification, both with the help of the chromatographical methods. Real life examples of the applications of the chromatography. Pharmaceutical company, I just told you that how the particular drug has been taken care of, whether the particular drug is pure or not. In hospitals, we can detect so many tests, we can do so many tests with the help of the chromatographical method. Law enforcement, whether a particular DNA is matching with the crime scene DNA or not, that can be done. Environmental agencies, you must have heard actually that so many industries have been given the closer notice. Why? They are doing pollution. How? The pollution control board, they comes to know that you are involved in a pollution. There are so many methods they are doing, and one of the method is the chromatographical method. Manufacturing plant. Suppose we are mixing a component A and B. You are having product C. Very simple looking, but when you go into the industry, then it is not that easy. It is a complex process. It's not like that you are mixing A plus B, giving the temperature 70 degrees Celsius temperature and running the reaction for 2 hours. No. If these 2 hours means for industry, it is 120 minutes. If the reaction is happening for 110 minutes, just 10 minutes less than what you are prescribing, then they can save lakhs of rupees. Not lakhs, overall crores are involved if a plant is bigger. Because they save so many chemicals, energy consumption, human hours, and so on. So, another thing, if you are exceeding than a limit, let us say time or temperature, then your product may go wrong. All these can be judged with the help of the chromatograph, whether your reaction is completed or not. And if it is completed, how much it is completed, when it should complete, whether your reaction exceeded, that can be done with the help of the chromatograph. So in manufacturing plant, to purify a chemical, to undergo a reaction, to do the monitoring of the reaction, chromatography is very useful. And obviously in research, so there are so many applications of the chromatography. In every industry, generally the chromatography is helpful. These are the different terms we are going to use in the chromatography. This is the illustration. We will go a little bit faster. Let us see one diagram, one GIF file I have made for the chromatography to understand. This is for, let us say, paper chromatography or thin layer chromatography. On a piece of paper or TLC plate, we are putting the drop of the particular molecules which are to be analyzed. When these plates are being placed into the container having the mobile phase, what will happen? The mobile phase will carry the particular molecule along with it. As the stationary phase is there on this particular plate, the molecules will run. And separation has been achieved based upon the affinity. You can see that all the three spots are at the same line when we have started. But periodically, they are being separated into 1, 2, and 3 points. So if you are having a sample which is mixture of these three, what will happen? This will three get separated out. And you will come to know that this is not just only a sample of one molecule, but it is the sample of three molecules. Hence it is a mixture. So by this way, you can do the separation. So how we can classify the chromatography? We can classify the chromatography. Let us start with the according to the mobile phase. We can classify it based upon the mobile phase. If the mobile phase is gas, the chromatographical method is to be known as the gas chromatography. If the mobile phase is liquid, liquid chromatography. And based upon the solid stationary phase, either it is the gas liquid chromatography, gas solid chromatography, or liquid chromatography, liquid solid chromatography. Liquid gas chromatography is not available, sorry. Or gas chromatography is not available because two gases mixes in any proportion. And based upon the involvement of separation, the principle, whether it is the partition chromatography, adsorption, molecular seals, or partition, adsorption, ion exchange, or GPC chromatography. So these are the classification of the chromatography based upon the mobile phase involved, based upon the solid stationary phase involved, based upon the stationary phase involved, or based upon the particular principle involved. These are the different types of the chromatography. We will go a little bit faster. So this is the example of the chromatography. Liquid chromatography, it uses a particular column and uses a liquid stationary phase. Thin layer chromatography uses the thin plate of aluminum, let us say, actually, to separate out the mixture. Paper chromatography, we use paper. Generally, these methods are available into our UG laboratories. So I have kept all of these dimensions. These are very basic chromatographical technique. You can easily develop. Even you can develop at your home. At last, I will tell you how some funny experiments can be done at home. Actually. This is the gas chromatography. Now, let us start with the theory of the chromatography. What exactly chromatography means and how we can do the analysis. How the results vary and what makes these results to vary. So if we think about a chromatography, what we think that we are introducing a sample and that sample comes out of the column into the sharp plug, means we will come to know whether the particular mixture which we are applying, it is a mixture of two or more component or not. This is our idea. And if it is happening, we can say this is the ideal chromatography. We are introducing the analyte and those analytes are coming very fantastic. Both are coming separately. This is called the ideal chromatography. So introduction of analyte in the form of sharp plug and it should come out in the same form giving the sharp peak is known as the ideal chromatography. Then non-ideal chromatography. The chromatography which we are dealing in daily days are non-ideal chromatography. And that's the reason we have to work hard. Or scientists are working hard actually to understand what is happening, what went wrong. So components in non-ideal chromatography, what is happening? You are introducing the component. It is in your hand. You are introducing means you are injecting the sample. And something is happening within the column. Adsorption, desorption. And the peak which you are getting, many times you are getting the peak like this, overlapping within each other. Or it is higher overlap or lower overlap. If you are getting such things, fantastic. You have been done. You have the ideal. But if you are getting these and these, then we need to answer why this is happening and how we can avoid this. I hope you are understanding. So why this is happening? This is happening due to the two theories are developed for to understand why this is happening. One is the plate theory and second is the rate theory. Before going to the plate and rate theory, we need to understand what is the distribution constant. What does it mean? Distribution constant. How your analyte or your sample is distributed among the stationary and mobile phase is known as the distribution constant. And how it is defined? It is defined with the ratio of the concentration of your sample within the stationary phase and the mobile phase. Then how much amount of your sample is within the stationary phase and how much amount of the sample is within the mobile phase. That ratio is known as the distribution constant. Second is the retention time. Retention time. Retain time. For how much time your sample is retained within the column. You are injecting the sample and it is going to the detector to detect. That time difference is known as the retention time. Peak resolution. You are introducing a sample, you are injecting the sample. Suppose it is a mixture of two components and you are getting both of the components separately out of the detector, through the detector. Fantastic. This is called a good resolution. Means you are resolving the peak. But if you are getting the peak like this, then these are not resolved. Means this is a mixture of two peaks. Sometimes what happens? You will get the peak like this. This is non-ideal condition. Means this is why it is happening. This kind of two peaks were there. They are overlapped. This one peak and this second peak. These two peaks are overlapping due to certain reasons, and that's the reason actually you are getting overlapping. So how much resolve your peak is named? These are the resolved peak, that they are separated from each other. This is called peak resolution. Column efficiency. How much efficient your column is. What is column? In which the stationary phase particle is placed and where the analysis is going to be done. This is called column. And how much efficient your column, if you want to know, meaning that how your column can separate the mixture. What is its efficiency is known as the column efficiency. And it is been defined by plate theory in the form of N equals to L by H. Well, N is the number of theoretical plates. This is just imaginary. In reality, it is not there. It's an imaginary. That number of theoretical plates equals to the length of the column divided by height of each plate. For example, you are having 10-meter long your building, in which let us say that you are having 5 floors. If you are having 5 floors, then N equals to your length of your particular building, let us say 10 meters, divided by each floor is having 2-meter height. Then total is number of the floor will be N equals to the total length of your building divided by the height of per floor. So 10 divided by 2 will be 5. The same way, your column is imaginary divided by number of the theoretical plates, and the height of each plate will decide the particular N value. And N is directly related to the column efficiency. The more the N, the more the efficient the column. यदि आपको N should be high, if you want the N should be high, then H should be very less. I mean, the theoretical plates, the height should be very small. And how it is defined? It defined the plate theory and rate theory. Plate theory was developed by Martin and Stringe, and rate theory was proposed by Van Dant. We will see one by one. What is plate theory? In plate theory, column is divided into number of adjacent imaginary segments. I just explained you by this way. So N equals to L by H, or we can say H equals to L by N. How the number of theoretical plates have been counted. So N equals to the number of plates, it is equals to 16 into TR divided by W, where W is nothing but the width of the peak which you are getting. As I told you, these are all imaginary, so you have to find out it with the help of the experimental data. You have to run your sample whose TR and everything is known. Mobile phase composition should be known. All the experimental conditions are known and well established. From that, the width of the peak is been established. And from that, these equations, you can find out the number of theoretical plates. The more it high, what will happen actually? Efficiency is good. So to make N high, the W should be very less. W half is the half width. If you can find out this one, actually this is the half width. What is going to happen? That is to be known as the W half. Now rate theory. This was the plate theory, now the rate theory. That from the rate theory, how the particular H is going to be calculated. So Van Denter, it gives one equation for the plate theory. Plate height H equals to A plus B divided by mu plus CS plus CM into mu, where CS is nothing but the concentration of your analyte into the stationary phase plus concentration of analyte into the mobile phase. A, B are constant. And all these three terms have their meaning. How? Let us see. A is known as the eddy diffusion. What is the meaning of eddy diffusion? You are injecting the sample and that sample is going through the column. Now, as the packing of the column is not good, what will happen? Your analyte will take different time to come out of the column. And due to that, your peak is getting broader. So from the ideal chromatography, you are going towards the non-ideal one. Your peak is not coming into the sharp plug, it is coming broad way. This is called eddy diffusion. Second is the non-equilibrium mass transfer. Your sample is not transferring equally. So due to that, what will happen? The equilibrium attainment is different. It will go from the higher concentration towards the lower concentration region. And that's the reason the peak is getting broader. And third is the longitudinal diffusion. What will happen? The more your longer of your column, the more adsorption desorption process will be there. And your solute has to pass a long time. And that's the reason what will happen, a time difference will occur. And as it is happening, your particular peak is getting broader. This is called as longitudinal diffusion. We will see by one video that how it works. So these are the reasons for the particular peaks to get broader and theories of the chromatography. Now, which are the factors they are increasing the peak resolution? Means you have to work upon which factors so that you can get the high resolution peaks and good separation. High resolution peak means good separation, achievement of the separation. First, increase the column length. Not all the time increasing the column length. You can say that you have to work upon the column length. Second is the decrease the column diameter. If you're decreasing the column diameter, it should be adjusted, you can say actually, so that your particular analyte can transfer it to the stationary and mobile phase. Decrease the flow rate. Don't make so fast of your column work. If you give more time, then resolution will be good. But yes, should not be that much slow that you will get one peak at 1 minute and another it at 30 minutes. Industry can't wait for that. Pick column uniformly. This is very important, that you have to pack your particular column uniformly. Otherwise, what will happen? The longitudinal diffusion may occur, or you can say that eddy diffusion may occur, or you can say that you are having the different diffusion actually. Non-equilibrium mass transfer can occur. So you have to pack your column very uniform particles. Use uniform stationary phase particle. Sorry. Decrease the sample size. If you are putting so much of sample, then the concentration will be very high. And it will stay within the particular stationary phase particle. It will block it. And you will not get a good resolution. Select proper stationary phase. You want to separate out the normal phase molecules, non-polar molecules, and you are taking the particular polar phase. Then it is not going to work for you. So you have to select the proper stationary phase particle. Proper mobile phase is needed so that it can carry a particular stationary sample molecule. But if you are choosing the wrong mobile phase, then what will happen? It is not going to carry it. It is not going to solubilize it. Then separation is not achieved. Use proper pressure. Use gradient diffusion. We will see what is the meaning of the gradient diffusion in coming slides. Now we are moving towards the advanced chromatographical technique, HPLC. Before starting with the HPLC, I would like to ask few questions actually to the audience. Unfortunately, we are not doing this class online or even offline. I'll answer all of them. What we exactly like to have? Ambassador or the fast moving Ferrari? Obviously, majority of us will choose this red one. The reason, it's so cool in looking and so fast in moving, so advanced, having all kind of the new technologies with it. Either we would like to have this or this. Obviously, we don't like to have the outdated versions. Reason, we can have the faster things, we can have internet kind of things in this iPhone or in the recent phones actually. So obviously we will choose these two actually over, we will choose these two over this and this. Reason, that these are outdated versions. No doubt at one point of time they were in action. They were in demand also. But now you can't find people who likes this too. Reason, we need to save the time. We want the best outcome. We want the best technology so that we will get the best result. This is the same thing with the chromatography. In liquid chromatography, if we are using, then what was there actually? In liquid chromatography, the glass or the stationary phase particle, they are packed through the hand pack column. And solvent is added, means your mobile phase is added. What is going to happen actually? Through the gravity forces, your separation is being achieved. Means your separation can take more than 2 hours, 3 hours actually, or more than even 1 day also. You can't wait for that. You need the technique which moves faster. So single analysis by classical liquid chromatography can take anywhere from 2 to 24 hours to carry out the experiment. But if some same experiment with high resolution is been done in just 10 minutes, then definitely everyone will prefer it. And HPLC can do that. Another thing actually HPLC can do is reproduce your result. If somebody is questioning you, you can definitely tell that yes, I can reproduce the result. So with the help of the HPLC, you can reproduce your results also. And not only once, you can reproduce thousands of times, hundreds of times. And number of samples you can do with the help of the HPLC. So what is this HPLC? It is high performance liquid chromatography or high pressure liquid chromatography. Definitely not the Hewlett-Packard liquid chromatography, but yes, it's little bit high price chromatography. So let us discuss about the high performance liquid chromatography. The basic components of the HPLC are solvent delivery system, by which we are delivering the sample, solvent. Second is the injector, by which we are introducing the sample. Third is the column guard, which saves your column, the main column, from the impurities, so that you can use your column for a longer period. Then main column, main heart of your particular instrument, which are having the stationary phase particle. In guard column also stationary phase particles are there, but they are of bigger size actually. So it is little costly. But main column is little more costly. Then the detectors, which are the eyes of the instrument, which will detect the analytes. Waste collector and recorder output is just a printer actually, to print your data. And waste collector is to collect the waste of your sample and the solvent. This is the modern HPLC diagram, how it looks. You can see over here. Now computerized, computer operated are there actually. This is the solvent delivery system in which the solvents are being placed, which are working as a mobile phase. It is, we are looking at a liquid chromatography, high pressure or high performance liquid chromatography. So here the liquid mobile phase is being used. These liquid mobile phase are injected through the column, and in column what we are doing, here is the column. So when the sample is not there, it will directly injected to the particular stationary phase particle, means the column. Then we are introducing the particular sample. So we are feeding the sample, we are injecting the sample. What this mobile phase will do, mobile phase will carry the sample component throughout the column. And here the separation has been achieved. And detector will detect that yes, your components are coming out. Whatever the waste material are there, they are being collected by the waste collection. And here from the computer printer, you will get the data output. So this is the basic idea about the modern HPLC instrument. A small video is there to understand how it is working. Let us see. This is the solvent reservoir where the solvent has been placed. These are the HPLC pump because we are going for a particular high pressure liquid chromatography. So what is happening here actually? The pressure pumps are there. Through that pressure pumps, through the pressure, the particular mobile phase is going into the column. So this is the solvent reservoir where the solvents have been placed. These are the pressure pump through which the pressure has been applied. This is the solvent mixing valve. If you are having the gradient dilution, then these mixing valve will mix both of the solvent. These are the degazers, will degaze the particular solvent molecule so that no air bubble will be there. Otherwise, it is affecting your gases. Then this solvent is going towards the pre-column guard or the column guard, which is saving your particular column. Now we are having the injector system from which the sample is being injected by the injector valve. And then it is going towards the particular analytical column where the separation is getting achieved.
With a stationary phase, and the commonly used stationary phase is ODS silica gel, and the common names of these columns are C18 columns. Next part is detector, and finally coming to the recorder. Now coming to the working of this HPLC instrument. So first we will start the HPLC instrument, then all parameters will be entered by the help of available HPLC software, and these parameters are solvent ratio, flow rate, run time, type appellation, etc. After creating the method, solvent of the mobile phase will be pumped by the HPLC pump from the solvent reservoir towards the degasser. Now these solvents will come to the degasser, and the degasser is attached with a vacuum pump which will create high vacuum. So any gas or air dissolved in the solvent will be removed online because this may create problem during elution. After degassing, solvents of the mobile phase will move towards the solvent mixing valve. In the solvent mixing valve, mixing of the solvents takes place, which will help to produce uniform mobile phase. Now this mobile phase will run towards the pre-column or guard column. So this guard column will remove any kind of impurity present in the mobile phase and protects analytical column from the impurities. In next step, mobile phase will further move towards the analytical column, then detector. In this condition, blank mobile phase will be run for 10 minutes at least, which gives proper conditioning of the HPLC instrument. Now we will inject the required amount of sample through sample injector by the help of a micro syringe. So after injecting the sample, it will enter into the analytical column which contains stationary phase. Due to the difference in the affinity with stationary phase, compounds present in the sample will be separated inside the column and reaches to the detector and gives signals in the detector. Compounds having least affinity with stationary phase will reach to the detector first, which is indicated by green color. Then moderate affinity compound will reach to the detector, which is indicated by yellow color. And finally, highest affinity compound will reach to the detector at the end, which is indicated by the orange color. Ultimately, all signals will be appeared in the recorder. For more details, you can.
So this is about a particular HPLC instrument, how it works. Now let's see the types of the HPLC separation. I hope that you have enjoyed the particular video. I will acknowledge the video at the last of the particular slides. So normal phase chromatography in separation of polar analytes by partitioning onto a polar bonded stationary phase is known as the normal phase chromatography. When you are separating the polar analytes, they are being separated on a polar bonded stationary phase, and that is being called as the normal phase chromatography. In the reverse phase chromatography, reverse has been done, means the non-polar analytes are partitioned onto a non-polar bonded phase stationary phase particle. Means your stationary phase particles are having non-polar group actually, like C18, C8 column. Generally, reverse phase chromatography are more useful. Adsorption chromatography, which is being used in between the normal and reverse phase. The separation of moderately polar analytes using adsorption onto a pure stationary phase like alumina or silica is being done. In ion chromatography, separation of organic and inorganic ions by their partitioning onto the ionic stationary phase bonded on a solid support has been done. And in size exclusive chromatography, based upon the size, the separation has been achieved. So separation of large molecules based in the paths they take through a maze of tunnels in the stationary phase is happening. So these are the types of the HPLC separation. Others are also there, but we are not discussing at this moment. Now the pumps, which are the most important component of the HPLC instrument. Why? The reason is that it forces the mobile phase so that it will run through the particular stationary phase quickly. So what are the characteristics of the ideal pump? First and most important is it has to generate the high pressure. And not only high pressure, but it should be pulse free so that continuous pressure you are going to get. And you will get the accurate control of the flow. It should be corrosion resistant. Otherwise, what will happen over a period of time? It will corrode your particular instrument, your column, and it will cost a lot. What is the role of it? To deliver the mobile phase. So two groups of the pumps are there: constant pressure and constant volume. Either you have to pump the volume constantly, or you have to pump the mobile phase through the constant pressure. So three types of the pumps are available. Reciprocating pumps, 90% of the commercial HPLC pumps are reciprocating. It produces pulse flow. Displacement pumps, they produce flow that are independent of the viscosity and back pressure. And pneumatic pumps, they cannot go gradient illusion. So this is the most important limitation of the pneumatic pump, that if you want to go for the gradient illusion, it can't work actually. And majority of the methods are of the gradient illusion actually. So very less useful. This is the reciprocating pump. In the reciprocating pump, what will happen actually, you are injecting your solvent over here. So once from the solvent reservoir, your solvent is coming over here, then what will happen? This ball check valve will open. Once it is open, your solvent will come over here in this reservoir. When your solvent is coming in this particular reservoir, what will happen? This motor starts working. And through the piston, it will gives the pressure to this particular way. So what is happening? You can see over here. It will come over here so that this piston will come out over here. And once it is coming out over here, this ball check valve will open. This will close. And here your solvent will be filled. Then the moment this portion is filled, what will happen? That these piston will again move upward, forward direction, and will pressure out this one with high pressure. And as this nozzle is very, very thin, what will happen due to this pressure? This ball check valve will open. And your mobile phase will run from here with very high pressure. Pulse damper are being used to, if any pulse damping is occurring over here, it will remove it. And you will get the pulseless flow into the column. Now your sample is going towards the column. This is the reciprocating. Sample injection systems. very unique sample injection system is there. It's not like that you are injecting the sample all the time. No. If you are injecting, then what will happen? The pulses will occur and it is avoided. So a sample injection system is being used. It is look like this actually. What is happening here actually in this is loop like actually. So the moment this is your sample is coming, initially it is this loop is closed. So what will happen actually? Your mobile phase is coming, your mobile phase will come and will go towards the column. You are not introducing the sample. This process is going as usual. But the moment you are introducing the sample, what will happen actually? That you are introducing the sample, so that sample will go towards this loop and directly come into contact with your particular mobile phase without affecting the flow of your particular mobile phase. And this loop will carry out the particular sample actually along with it. And it will go and feed into the particular column for the separation. So no dampening is going to occur. And your sample is going damp free actually into the column. No lagging is going to occur over here with this method. Whatever the waste material is there, that waste material will go towards the vat or the waste without affecting anything. Now these are the most important part or the heart of any instrumentation HPLC, which is the column, analytical column, in which the stationary phase particles are filled. Before the analytical column, the guard column are like this. We can save the particular main column from the particular impurities. In the guard column, the particles of the bigger size have been placed. Same particles to the stationary phase particle of the main column are being used, but little bit lower packed, bigger size molecules. They are cheaper. You can remove it and you can replace it easily. So in analytical column, it is of length of 10 to 30 centimeters, internal diameter of 4 to 10 millimeters, particle sizes of 3 to 10 micrometer are being used of the pore sizes, and internal diameter of the 5 micrometer particles are being used. So this is the main area where the stationary phase particles are packed. Now, optimization of the separation in HPLC. How to optimize your result, how to get the better resolution, better peak resolution. So, correct choice of the column is very important. That you are choosing a stationary phase of right choice. Then comes the correct choice of the mobile phase. Suppose you have done everything perfectly. Then comes actually how you are running your mobile phase. How your sample is coming in contact with the stationary phase particle in which proportion. That is very important. So there are two ways. Either you are running the constant composition mobile phase or you are running the varying composition. When you need the high polarity, you run the high polar mobile phase. When you need the least polar, then you run the least polar mobile phase. And when you need the intermediate one, run the intermediate. This is called the gradient illusion. That for a certain time period, you are running only the polar mobile phase. You are having, let us say, suppose two reservoirs for the mobile phase. One is filled with the particular highly polar solvent and one is with the least polar solvent. When you want the high polar solvent, because your molecules, the mixture is having the polar plus least polar molecules, then what will happen actually? The polar molecule needs the more polar mobile phase and the least polar molecule needs the least polar mobile phase. So for certain time period, you will run only the most polar mobile phase and then you are mixing them, making the moderately polar mobile phase. Then over a period of time, you are running the least polar mobile phase so that your separation is achieved in a good form, least time. It is called a gradient illusion. So determination is then you have to determine whether the flow rate is perfect or not. Not too fast, not too slow. So you have to establish a decision on the heating of the column, whether your sample molecules need the heating actually, so that the separation is fast. This is very unique things to do. And it can be done with the help of the experience. And experience of your sample components, that which sample components are there, whether you need to heat it or not. Based upon that, the separation has been achieved. Stationary phase is generally the polar or the normal phase. We use silica, alumina, cyano, which are the polars functional group actually. So these functional group terminations on the bonded phase are there, so that your polar molecule will come into contact with this polar functional group and the separation has been achieved. In the reverse phase, you are having the alkyl chain, higher alkyl chain from C8 to C8 in terminations on the bonded phase, so that the non-polar mobile phase will come into contact. Non-polar molecules will come and separation has been achieved. Tuck particles in a column require fluids at the end of the column to keep the particles in, filtering the samples to prevent the clogging of the debris. High pressure pumps and check valves of a guard column is used. Now the mobile phase is in HPLC. How it should be? So it must do the following. First, it should solvate the analyte molecules and solvate therein. And it should be suitable for the analyte to transfer back and forth between the during the separation process. And it must compatible with the instrument, compatible with the stationary phase, readily available, adequate purity, and not too compressible. Otherwise, what will happen? It causes the pump or the flow problems. And it should be free of gases, otherwise dampening will occur actually. And compressibility problem will occur. So these are the characteristics of the particular mobile phase. Now, how the optimization will help in getting the good separation. You can see in this particular case, we will go a little bit quickly, that if you are having the 90% of the B mobile phase, then these 8 components are not separated. You will get only 3 peaks. Hona kya chahiye tha? That you should have get 8 peaks separately. That you are having 8 components into the mixture, but you are only having 3 peaks. Then separation is not good. Now, if you are running the 80% of B, let us say B is, let us say, suppose a non-polar mobile phase, then you will get the separation like this. Still, if you go with the 70% of the B, you will get the peaks like this. But if you are going with 60% of B and 40% of the A, then you can say that you are having the good separation of the peak. So just by changing the percentage composition of a mobile phase, you can see that you are getting good separation. This is how the optimization has been done. So if you are changing the mobile phase composition, then how the separation is getting achieved. These are the difference between the isocritic versus gradient elution. We just see that in isocritic elution, what is happening? You are running a same composition of the mobile phase throughout the column. Within the gradient elution, you are changing the composition of the mobile phase based upon your requirement. And gradient elution is really helpful. This is the way. Initially, you are starting with only 30% of the acetonitrile. Then you are going with the 45% of acetonitrile and 80% of acetonitrile. You can see these guys are having good affinity towards the acetonitrile. And these are having very good affinity towards the acetonitrile. So if you are running, then you will get such kind of the particular separation. If you are not running it, and only 80% of the acetonitrile will run actually, then here you will get breaking. All the 8 peaks will be coming over here, which is not required. You will not get good resolution. To have a good resolution, you have to run the mobile phase very smartly. And this has been done with the help of the gradient elution. Let us see one video to understand this. The difference between the isocratic and gradient illusion. In isocratic analysis, component used for the routine analysis of one or two compounds in a single run. Generally, when you are having the less samples present into the mixture, then this has been used, where same mobile phase is running throughout the column over all the time. The mobile phase is polar. So what will happen? It will stay longer. So depending upon the affinity, it passes the time into the column. And one will come faster, one will come slower. So in isocratic illusion, you can see that one is coming too fast and one is coming too late. Means it takes a longer time period. It's not good. So what we will do? We will change the isocratic illusion to the gradient illusion. So a mixture of two mobile phases is also considered isocratic analysis as long as the composition stays the same. Now we have changed from 100% of the polar to the 90 and 10%. So what will happen actually? It depends upon the composition, and based upon that, you are getting the resolution to achieve. So now, if earlier the resolution is of 10 minutes, then it will come to the 8 minutes. Still, this red guy is taking longer time actually to come out. So what we will do now, suppose blue guy is coming at adequate time actually, you need to come this particular B guy very quickly. So what we will do, we will improve it with the help of the gradient illusion. So now we are running it. Initially, we will just pass 100% of the particular polar so that your blue guy will come quickly. Then we will separate it out actually 50-50%. Let us say the higher the non-polar we will run actually. So what will happen? We will get really good resolution. And very small time, we will get both of the peak separated out. So this is the difference between the gradient and the isocratic illusion, and how it impacts the particular time as well as the analysis. Now comes the last part of the chromatographic methods, which are the detectors. What it will do, it will visualize the compound which have been separated out, which are the eyes of the instrumentation. So it visualizes separated compounds and translate the concentration changes into the signals. The characteristic of an ideal detector is it should be having adequate sensitivity, good stability and reproducibility. It should give linear response to analyze that have several ranges of magnitude. And it should have short response time. The moment the sample is coming out of the column, it should detect it, not taking the longer time to detect. So short response time, high reliability and ease of use. No need to derivatization, something like this, or mathematical calculation. No need to it. Just it should give you the data. Similarity in response towards all the analytes. It should not like this, it should give only to the fluorescent molecule. No. It should have uniform. That your detector should detect all the compound uniformly and non-destructive. Your sample should not get wasted. Like in FID, film ionization detector in the GC, you are wasting your sample. It should not be like this. You can preserve your sample. Basic types of the detector are the bulk property detector and solid property detector. In the bulk property detector, it responded to the mobile phase bulk property, like refractive index, dielectric constant, density. And solid property detector, it responds to the property of the solid, like whether it is a UV responsible or whether it is the fluorescent. Popular type of detector are the UV visible detector, fluorescent detector, least useful, RI detector. 1 and 3 are more useful actually. In the UV absorption detector, what will happen? Your sample is UV active. So what will happen? Compounds with strong UV visible chromophores are used for this kind of the detector. Detector are used for this kind of the compounds. The advantages are very small amount of the sample is needed. It is very simple, reliable, inexpensive technique and compatible with the gradient diffusion. And disadvantages, the sample which are not UV active, they are not being analyzed. And for them, you have to derivatize the sample with the chromophores so that you can detect them. Vitamins, carotenoids, phytonutrients are being analyzed with the help of the UV visible detector. Diode array detector, the most important and useful in the pharmaceutical industries because it is non-destructive, non-universal. And it can have hundreds of UV in each of the particular analysis. But huge volume of data. And many times it requires a huge amount of the solvent. It's versatile. For any particular sample, you can use it. Fluorescent detector, the most important disadvantage is actually if your sample is not giving fluorescent, then you can't use it. But yes, it is very accurate and very much precise and very sensitive detector. RI detector, it depends upon the change into the refractive index and it responds to the analyte through the changing of the RI of the mobile phase. It is very temperature sensitive because refractive index change is based upon the temperature. Advantages, it is universal into the nature, and disadvantages, little bit less sensitive and impractical for the gradient diffusion. Several organic solids, organic acids, sugars can be used with the help of the refractive index detector. And the last part of the instrumentation is recorder, which is nothing but the printer, by which you will get whether which particular peaks are coming at which time. So this is the data collection. So this is all about the HPLC instrumentation, chromatography, and its advanced technique of the chromatography. For any questions you have, you can contact me through email. Even if you want to collaborate with our laboratory, you are most welcome to collaborate. We are really happy to help you in any kind of the science related problem related to chemistry or any other technological innovations. We are happy to help you. Even you can contact the organizers so that you can directly contact us. We are happy to acknowledge, I'm happy to acknowledge actually my group members. 6 members have already got their PhD degrees from my laboratory, my collaborators, and definitely the funding agencies. Without their support, it's very difficult for us actually to carry out our research. So I'm thankful to organizing committee to giving me an opportunity to present the chromatographical methods to all of you. These are the references from which we have taken made this particular presentation. Thank you. Thank you so much. If any questions, you can write me through my email or you can contact the particular organizing committee. Thank you once again.
Thank you very much, sir. It was very nice and informative session for all. Thank you very much once again.